Hello everybody, today I'm going to be talking about finding the probability under a z-curve or a standard normal distribution using a calculator. Okay, instead of going through showing you what the calculator does, I'm just going to go ahead and show you an example. So let's go ahead, or a few examples. I gave you a normal curve and the average of the population is 60 and the standard deviation is, let's say, 6.2. Okay, so graphically this looks like this. The typical distance away from 60 is 6.2. And let's say this was a quiz scores and the test was let's say out of 80 and the average was 60 with the standard deviation of 6.2, and you came in and you got a 64. Okay, so you're a little bit above average, and I'm going to say what's the probability that somebody else also got a 64 or more. Okay, and then continuous data, it doesn't matter if this is a greater than or equal sign, or greater than or equal sign. Okay, so I'm going to show you how to do this. So I'm looking for this area to the right of this 64. So if you saw the other video, we want to go ahead and standardize this value. We want to standardize it, and because this is like the distribution of x's, I want to standardize this and turn this into a z. Okay, and the mean of the z is 0. So I'm going to turn this into a z. So this probability that z equals, so let's find our z, which will be 64 minus 60 divided by 6.2. Let's bring my calculator in. So it would be 64 minus 60, enter, divided by 6.2. So I get this long number. I'll go ahead and round it to thousandth, which is the third one over. Okay. So basically I'm looking for the area to the right of 645. Let's shade this in. Okay, so the way the calculator works is you're going to put in, okay, I'll show you where this is at, but I'm looking for normal CDF. You want to put in this value. This will be your start. That'll be your start, 0645. And what the calculator does is it scans. It scans across. So it's gonna look across here. It's gonna keep scanning. It's looking up here. It's taking all these values and finding what the area is. So it's gonna keep going and going and going and going. And eventually you want to pick something really, really far. Pick a really big z-score. So we'll say 1,000. You just have to make sure you pick far enough away that you wouldn't pick here because you would lose this. So you want to make sure you pick really, really far away. Okay, so let's bring my calculator back in. Okay, and I'll show you where to find this normal CDF. It's a CDF, it's a distribution. See, distribution is right above the R, so you hit second, vars, and I want to come down to normal CDF and hit enter. Now if you see, I have my number stored up here. Okay, now even though I rounded it here, I don't want to round it. I want to take this whole thing and put it in, and what we could do is we could use, that's stored in the answer. So if I hit second, answer, that's actually putting 0.645161293 down here. That's my start, and I want to end it at, just pick a big number. Okay, just pick something very, very large. And go ahead and put enter, and this is going to be equal 0.259. Okay, so about 26% of the x's will fall above 64. Okay, let's go ahead and do another example on the other side. We'll do two more examples so I can show you every one. So I'll change this up here and I'll say this is 42 and 7.5. Okay, so I'm going to say find the probability that we randomly pick an x value and that x value is less than 33.1. Okay, so I'm making it a little trickier now with decimals, but the process is still exactly the same. The middle here is 42. The point that I'm interested in is 33.1, and since this says less than, this is less, then I'm interested in shading this thing to the left. Okay, so the first thing I have to do is I have to standardize this x-score. I have to turn this x-score into a z-score. Okay, standardize it. So my z-score equals 33.1. It's the x value minus the mean, divided by how much standard deviation we have in this distribution, 7.5. Okay, so 33.1 minus 42. Enter, divided by 7.5. Okay, and I'm going to show you a little trick when the numbers get a little crazier. When the number gets a little crazier, or anyway, this is a great strategy to use. So I'm going to take this number and I want to store it into a variable. So I'm going to hit store, STO. I want to put it in this variable A right here. So I hit alpha A, okay, and I hit enter. Now anytime I want to use this number, negative 1.18666, I can use A instead. Okay, so I'll just write this as a way. I'll say store in A, and I'll put an A right here. Okay, so now I want to do normal CDF. So remember, the calculator always scans from left to right. So now what we want to do is we want to pick a really small number. Now I'm talking about this graph right here. I want to pick a small z. I'm actually in z's right now, so I'll use the z to show you exactly what we're doing. This is z, this is negative 1.18. Scan up. This area right here is the same as this area, so what the calculator does is it reads from left to right. So you want to pick a z-score way over here to guarantee that there's no frequency. You did no frequency. There's no line above it. So we'll pick negative a million or whatever you want. Just make sure you pick something big. And we want to go all this way. We want to stop here. And what the calculator is doing is it's looking. It's looking. Here's all 0, 0. And then all of a sudden it starts picking something up, and this is where we want to end. So we want to end at, I have my data, I have this number into A, so I could say A right here. So now I want to go to my distribution, so second distribution, down to normal CDF, and I want to put in a very small number, negative, comma, and now I want to pick A, alpha, math, A. Let's go ahead and close our parentheses and enter. In this area, right here, we pick a different color. This shaded region here is almost 12%. So this is about 11.77%. Okay, and the last one we'll do is the most trickiest way to use with the chart, and that would be, let's find a number between 40 and 50, or find the percent that'll be between 40 and 50. So I'm finding that shaded region. Okay, so the first thing we want to do is standardize. So Z1 equals 40 minus 42 divided by 7.5. We want to find Z2, which is 50 minus 42 divided by 7.5. We want to find both of these numbers, and we're actually finding the area on a z-curve. This is 0. Okay, so let's go ahead and do this. 40 minus okay, so this is negative 0.26667. I'm finding the other one now. This is 1.06. Okay, so this is negative 0.26667, and this is 1.06667. And I'm finding this area right in between here. The way we do this mathematically is we'd say, what's the probability that negative 0.2667 is less than or equal to z, because I'm doing it on z's. That's what this looks like. And this area right here, will be the answer right here. So what I'm going to do is, I'll just go ahead and do the z. So second distribution, go down to my normal CDF, and I want to put the one on the left, which is negative 0.2, just put a bunch of sixes and a 7, and you could store this also the same way. You could put one in A and one in B, and the other one will be 1.0. Okay, so the area in between this is about 46%. Okay, so that's how you do it. So I appreciate you watching. Thank you so much, and have a nice day.